Thank you, Bianca. I'm gonna go ahead and share my screen, make sure that works, and then we'll go ahead and get started. All right, thank you everybody for joining us today. I see some very familiar names as well as some new names on the list here. So those that I do know, welcome and appreciate you joining again today. I think you're going to see some new information here that you haven't seen before. And to the new names on the list, I hope I get a chance to meet you either virtually or in person in the near future. My name is Mike Complita. I am a principal at Elliott Bay Design Group, and here to talk to you today about an exciting new project that we've been working on that I think you'll all find very interesting. Let me get to my page to change the channel. 1 second. There we go. So before we jump into the technical content, just give you a little bit of my background, why I'm here presenting to you today. I am a licensed naval architect. I have been in the industry for a little over 30 years, actually going on 31 years. And the majority of my work over that time has been in the petroleum and chemical transport sector, as about 50% of my focus. And then the other 50% has been working with shipyards on construction of all different types of vessels in an engineering support role. The last 3 or so years of my career, I've really been gaining an expertise in alternative fuels and technologies. And the reason I have expertise in quotes there is that it is changing so fast. I think we all know the landscape is changing so fast. The technologies are evolving, new things are coming online, that it's a constant effort and it's really quite exciting to keep up with it. So I don't know that anyone is truly an expert in all alternative fuels and technologies, but certainly working hard to stay ahead of that. So myself and my firm can advise our clients on that. And I'll also add, my wife likes to call me a weird engineer because I have a passion for industry engagement and talking to people in general. I also like public speaking and presenting. Frankly, I'd rather do this in person with you all than online. But since we're all spread all over the country, this is a great way to do it also. So today in our webinar, you're going to learn a few key topics related to the project that we're working on. The benefits, first off, the benefits of barge-based shore power. And secondly, how that shore power, how generating that power compares with the emissions profile of conventional landside grid power. We're going to talk about what it costs and options for grant funding. Although I will admit with the current administration changes this week, that is a little bit up in the air, but we'll talk about that in a little bit later in the presentation. And then lastly, we're going to talk about timing and how soon we can put this to work for your port. I like to share this graphic to start the conversation because it really demonstrates that maritime emissions, those blue bubbles there show hotspots in maritime emissions around the United States. And as you can see from that, it really affects everywhere along all the coasts, including the Great Lakes, the Gulf, East Coast, West Coast. There really isn't anywhere that is, independent or immune from maritime emissions, and it pretty significantly, obviously, in the key port areas around the country. I really love to share this graphic with presentations I do on this topic. We talk a lot about maritime decarbonization, and there is an element of decarbonization I have heard referred to as the most challenging 15%. And the graphic of the port view there, that photograph of the port, really helps drive home why it is so challenging. As you can see, there's at least a couple dozen ships in the harbor there. Every one of them is different sizes, different configurations, different cargoes. I think way in the back, that white little stripe there under the double L in challenging looks like a cruise ship, even at anchor there. Every one of these vessels in port at anchor is running their generators, running their power, keeping their systems on. Even when they go to the berth, they're running their systems or plugging into shore power. How do we get these vessels to be able to turn off their generators and or run them in a cleaner fashion so that we're not putting out emissions into the harbors and into to local communities? Other aspects that make maritime decarbonization challenging are shown in those images below. You see the size of equipment that's necessary to facilitate shore power at a single berth in that bottom left picture, just a massive size of equipment to manage all the power. In the middle, you can see a single tug that's an electrified tug that will plug in to the shore. We need a berth for that tug. It normally takes at least 4 hours for fast charging, and in some cases can take a day or more to fully recharge a vessel's battery banks. That that vessel's taking up a berth, that vessel's taking up space in the port. So it's really dedicated to that vessel. If they're running half a day and then coming back to charge, you need a dedicated space for that. And then we also have other operations like dredging and general maintenance. How do we electrify or otherwise reduce the emissions of some of those types of vessels that aren't really that well adapted to electrification or need to be out in the field operating 24/7 and not able to come back to the dock and recharge on a regular basis? So this slide here, please don't put too much effort into reading that tiny text. I apologize for that, but it is a graphic that I think is very powerful. Just seeing the colored bars, each one of those colors in those vertical bars represents a different segment of the maritime industry. And in California, you can see that the relative height of those bars, where they're at now with their current regulations and where they're headed to in the future by 2035, that's how much they're looking proportionately to reduce maritime emissions. And I know everyone thinks, oh, California, they're doing their own thing. You know, you've got California Air Resources Board, CARB, doing what they're doing. They're out there ahead of everyone. That's not really affecting our state, but I'll tell you, it is coming to most regions of the country. Washington State, where I am a resident of, is now preparing to fund a study to implement the CARB ocean-going vessel regulations. That's the ocean-going vessel at berth regulations. So when a ship comes in, requiring it to plug into shore power and or have another means to basically eliminate emissions. That's Washington State alone. I know other states are considering that. To my knowledge, 11 states are considering some form of formal regulation for harbor emissions. And I also know in talking with all of the major ports and intermediate-sized ports that everyone is looking to reduce emissions to net zero or some form of zero or close to zero by 2050, and in some cases even faster than that. As many of you may know, and if you haven't already looked into this, you will quickly learn. Oh, and by the way, let me say thank you all for putting your questions in along with your accepting the invite to this. It was very helpful. I was not surprised by a lot of the questions and comments that I saw in those because they are themes and challenges that really every port is dealing with, or at least most ports. Even though all ports are unique in their own way, they all have similar challenges. And some of those challenges are listed here. Grid capacity is a major one. Some ports don't have a problem with it, but a lot of them do, especially more rural ports or more remotely located ports. The grid itself just does not have the capacity to provide multiple megawatts of shore power to be able to turn it on and turn it off and serve these ships as quick as they need to. Available space, we touched on that a little bit earlier with the equipment that we need shoreside to manage it, with the cable systems running down the pier, with the plugs, with everything, with the different ships coming in. Where do you put all of these plug spaces and how do you keep it out of the way of the different terminal cranes and other things that are moving? Permitting is another big one I hear continually. Most ports are facing 5 to 7 year processes for obtaining permits to bury copper wire to run that power from the street out to the berth. Installation time, cost, interruption, those all tear up the port, tear up your facility, impact operations, impact your bottom line. How do we take that away from the challenge of installing shore power? Of course, you have ongoing maintenance, and also what happens in the case where the power grid goes down. What do you do in that case if there's a brownout or a fire like we see in California, a hurricane in the Gulf Coast, other factors that may impact or shut down power on a long-term basis? We are proposing a solution that is completely independent of the grid, and we are titling it CHAMP, which stands for Clean Harbor Alternative Mobile Power. You can see why we gave it a catchy name. As you can see from the image there in the blue picture, or the blue vessel down there, it is a barge-based power generation system. And I will admit that putting a generator on a barge is by no means a new concept. It's been done for decades for all types of reasons. But actually, you may be surprised to find out that as of this date, no one has ever put a large power generator on a barge specifically with the intent to provide ship-to-ship transfer of electrical power. And so this would be a first of its kind anywhere in the world. There's a lot of benefits to basing this system on a barge. As we mentioned earlier on, power grid independence is a really key factor. We move this barge into position where and when we need it to serve a vessel, or in some cases, it can serve multiple vessels at once. It is mobile and flexible because it is barge-based and moves around the harbor on a tug. We can serve ships at the dock. We can also serve ships out at anchor. That's obviously going to be a more one barge to one ship ratio when it's out at anchor. We can also use it for strategic fast charging. A lot of ports having electric vessels or looking at electric tugs and other types of electric vessels, pilot boats, and that kind of thing. If it's a pretty compact port, they can charge at the dock, go do their job, and come back. Others, certainly like Seattle and Tacoma area in the Pacific Northwest, the tugs have to go very far, many, many miles to pick up their escort vessel that they're escorting into the port and bring them back in. When they get to the point of picking up the ship, they may be out of power or not have enough to get back. So we can strategically locate this platform. The tug goes out, pilot boat goes out, plugs in, waits for the ship to show up while it's recharging. While it's fast recharging over a period of about 20 to 30 minutes. Now it's got all the power it needs to come back in. Emergency power supply or port resilience is another one that we think is a really key factor of this. And something I really like about this approach is that we can be using it to generate revenue for the port, or at least providing shore power to these vessels on a daily basis to reduce emissions in port. And if there is an emergency, we can simply disconnect it from the ship, plug it into a compatible connection on the shore, or some other form of providing emergency electrical power. Of course, at that point, the ship turns on its generator, but in an emergency situation, that's a pretty low impact and cost to pay to be able to provide 10 plus megawatts of power to the shore. We have multiple fuel options for this approach. Certainly, we can look at alternative fuels such as methanol and ammonia. We'll get into those technologies in just a little bit. We can also run on conventional diesel or biodiesel with some very impressive emerging technologies that clean the exhaust systems. This approach has no construction impact or permitting to your port. It will be built in a shipyard or can be built on an existing hull in a shipyard or another fabricator, completely tested pier side, and then brought to your port and effectively be turnkey ready to go on day one when it arrives. Depending on the technology we choose, it will have lower, as certainly in all technologies we're applying to this, will have minimal environmental impact, but we can actually have lower full cycle emissions and even lower localized emissions than the grid power that you would be using to charge your ships from the shore side, which I think is pretty exciting to be able to even improve upon the emissions profile of grid power. And then certainly we want to be considerate of cost. This has to have a low cost to implement and certainly a low cost to operate in the long term as well. And we can do that through a variety of ways, the technology options we have available to us, also the potential for recycling surplus barges. There are a lot of surplus double skin barges and other compatible platforms that could be reused for this, or we can construct new. And we'd also be looking at federal and state grants to fund a lot of this as well. Now, I mentioned earlier that this is certified by the U.S. Coast Guard. I guess I didn't mention that. This will be certified by the U.S. Coast Guard as an independent vessel. That does really play into the permitting factor, and it's a real benefit for the permitting factor. When we first came up with this concept and thought, hey, wouldn't it be great to be able to provide power to other vessels, we approached the Coast Guard and we said, hey, this is what we're looking to do. And the Coast Guard said, yeah, no problem. People do this all the time. You're just tying it up to the dock, correct, to be able to do that? And we said, no, absolutely not. Our intent is to be able to take this out into the harbor, to move it from berth to berth, to be able to serve vessels away from the dock. And the Coast Guard came back to us and said, wow, no one's ever asked us to do that before, and we're not even sure that we're allowed by law to regulate a vessel of that type. And we said, oh my gosh, what do we do in that case? Who would do that? Somebody has to regulate this. So they said, let us go talk to our legal department. And I'm like, wow, legal department? I didn't know the Coast Guard had one. I've been in this business a long time. That was news to me. They spent about 2 months talking about it inside the Coast Guard, and their legal department did return a letter to us specifically stating that they will consider this an inspected vessel and take over the inspection responsibility. I will also admit that I really like the Shark Tank. It's a guilty pleasure of mine, and my favorite shark on that is Robert Herjavec. This is a quote of his: "Someday isn't a real day like Monday or Tuesday. It's just another word for never." And I really like that quote, and it applies here because the technologies that we are pursuing or we are proposing for this application, we feel very passionately need to be proven existing maritime technologies. We can't promise you something that is going to be sometime in the future. It doesn't do you any good today. So the technologies we'll be getting into here shortly at a very high level are all commercially available to you today. So as we started to develop the design, the first thing you do in any design process is come up with an initial concept. And this is a very rough idea, our very first rendering of what that looks like, taking a conventional bunkering barge hull, if you're not familiar with that term, basically a fuel barge that would collect, take fuel from the shore out to and transfer it to a ship so that it can run. We don't take the ships, as y'all probably know, we don't take the ships to the fuel dock. The fuel comes to the ships. And so we took that and said, okay, we're going to put power generation on top of that and use the hull tanks to be able to provide the source of fuel to the generating system and then generate the electricity. So in talking with different ports and talking with different vessel operators, everybody we thought would have input on this to decide what levels of power we need. The first thing we learned is that the power range is pretty big. So at the low end, we need somewhere around 3 megawatts of power to do most cargo ships. We need 3 to 5 megawatts to be able to run refrigeration on refrigerated cargo vessels. As we start getting up into oil tankers and things like that, some of their pumping systems require more like 10 megawatts of power. And then as we get all the way up to cruise ship level power, we're looking at somewhere around 15 to 16 megawatts of power. So we need to be able to accommodate a very wide range of power demands. If we're doing harbor charging or fast charging, electrical charging of battery systems in harbor craft, that's a very different approach. We need about a megawatt of power for that with a 10 megawatt hour reserve. So rather than one big generator providing AC power, we're going to use a much lower power level system that runs consistently like a trickle charger, constantly refilling that big battery reserve. And we use that battery reserve then, just like we would on shore, to fast charge the battery system in the tug. And then the last bullet point there, the 30-day duration, we felt it essential that this system cannot take a lot of time at the dock. It needs to be out doing its job. It can't really require or demand having berth space. This vessel, with the capacity we have here in about a 200-foot length of barge hull, can be operating in that kind of 5 to 8 megawatt range for 30 or more days, running 80% of the time or at 80% of its total generating capacity. It can be out operating for 30 days without needing to return to the shore to take on fuel. When it does, based on the capacity that it has, it takes about 4 hours to refuel. So it really does not ever need to spend more than half a day at the dock at any point during its operations. So that was the initial concept, and then we moved into refining our design goals as we developed it further. We talked a lot about this already, so I'll just hit some key bullet points. We really wanted to focus on minimal impact to your port operations and your infrastructure with the offsite construction, infrequent refueling, and simple storage, again, being a compact hull form, a compact size. And then we really wanted to also focus on the flexibility, which we all know we don't have from conventional shore power. So making it mobile is key. Being able to serve vessels of all different sizes, being able to scale power level, and then as we touched on, providing emergency service are all key to the flexibility of this. And once again, we really doubled down on our focus to make this as cost competitive as we could with grid power. So the barge hull itself is very basic, very simple, very known and understood. It's the power generation technology where we start to get into the more complex aspects of this, and also understanding what the different fuel types are and what the pros and cons of each are. We started working with Wärtsilä on this and looking at their new methanol fueled L32 generator unit. We started focusing on methanol initially, and it's still a very viable alternative for a number of reasons. Most of the ports and folks that we talk to like the idea of methanol. They like the green factor of it. They wanted to move away from diesel. They wanted to move away from other types of fuels like LNG that are more fossil fuel based. There was also a lot of resistance. We talked a lot about ammonia. There was a lot of resistance to that, some fears about toxicity and availability and other things as well. And then we thought there would be a lot of interest in pure hydrogen, but we were actually quite surprised to find that most people, as much as they like the idea of zero emission from hydrogen, it's just too complex, too costly at this point to be a very practical solution. And so working with Wärtsilä, we learned very quickly that their L32 engine is a perfect size for this. It can run on methanol or biodiesel together. And we can even further improve the emissions from that, enhance the NOx emission reduction with the addition of selected with an SCR system. Since beginning this effort, there's a lot of new technologies that have also moved from the research phase and the development phase and the regulatory understanding phase into being viable and being installed on vessels right now. And a lot of these technologies are really focused on conventional diesel and biodiesel and synthetic diesel, the fuels that we're used to. And that brings us a lot of benefit. Number one, these different diesel options are considerably less expensive than some of the alternative fuels, especially the green alternative fuels like methanol and ammonia. These systems are simpler to put in. Diesel is also a low flash point, or is not a low flash point fuel. So it solves a lot of the regulatory challenges and concerns as well from the Coast Guard and some of the safety factors that the port safety authorities will have with some of the other options. So we have a number of options now available to us. Carbon capture system, that's kind of all I'll say is the holy grail of how to clean up diesel emissions. That one is more complex and more expensive. We have simpler solutions as well, diesel particulate filtration and exhaust gas recirculation. Those are very effective systems that take up a lot of space on vessels. But because we have a barge-based platform, we have a lot of room to use them here. They are more cost-effective and very effective at reducing emissions. And I think that's an important piece to point out too. While we can put these systems on the ship, every ship will need one of these systems. Very costly, it take up a lot of space. We can put one system on one barge and serve multiple ships with that. So I think you can all understand the cost benefit of that. And then, of course, with this system, we can also apply that same selective catalytic reduction or SCR system to significantly reduce the NOx emissions. And this table here, you don't need to study it all, but just a good visual graphic, just kind of focus on the colors. Oh, by the way, let me mention this recording will be available at the end of the presentation, so you can watch it back in time, and you'll have access to all of these slides as well. But this slide here put together a table effectively to give you a sense of relatively how green or how much impact on emissions reductions some of these different technologies have. Also relative to their cost, their lead time to buy them and have them produced and put into operations, and the regulatory challenges with getting them implemented. Of course, not surprisingly, the ones that are significant improvement in emissions reductions, but not the extreme improvements, they're low to medium effort to get through the regulatory process. They are still new and relatively novel, so it's not just a simple rubber stamp, but not too heavy of a lift to get it through the regulatory approval process with Coast Guard. As we start getting into some of the more exotic elements like carbon capture and hydrogen fuel cell that significantly lower the emissions almost to zero, vastly better than even the grid. They're great, but there's a lot of challenges with the regulatory side of things, with lead times, and with the overall costs. Something else we considered in the design process, we said, we're putting a really, really big generator on a barge, and great that it's going to clean up the exhaust emissions, but if this thing is crazy loud and it's just making so much noise at the pier, no one's going to want it, and it's going to create its own alternative form of pollution, and that'd be noise pollution. And so that's something else we work very closely with our technology partners to ensure that every different type of technology we are proposing is going to be operating outside the vessel, not inside the engine space, but when you're outside of the vessel on the dock or on the deck of the vessel, down in that 35 or lower decibel level. In some cases, it's down closer to 20. Depending on the technology, but certainly at that library level of quiet. We need this to be as silent or as invisible as possible from a sound perspective, from a pollution perspective, and also from an optic perspective. We're working on how do you make a barge with a box on it somewhat attractive to look at. So taking all of these factors into account. We touched before on or talked a lot about how do we provide big volumes of power to the ship. I also wanted to just briefly touch on harbor vessel charging. Right now, I know that battery-powered vessels and vehicles are not really in favor with the new incoming administration, but I think that their time is coming, and we will see more of those in the different ports. And as I mentioned early on, we are looking at a version of this that can be positioned out in harbor or out somewhere strategically to be able to charge vessels. And we do that, as I said, very differently. We are looking at using either ammonia or hydrogen reforming technology to extract hydrogen from those fuels, from those liquid fuels, because they're very energy dense and can store a lot of hydrogen, and more safely than hydrogen itself. Put those through fuel cells to generate power and charge our battery reserves. And what that does, as I said, is continually charge that battery. It doesn't matter how much power the tug or the other vessel's drawing, it's just continually trickle charging and filling up that reserve, and we're sucking it away as we need it through the vessel connection to charge those. This approach has essentially near zero emissions, potentially zero emissions, depending on the technology that we apply, and it operates almost as silent as your refrigerator. So let's talk about cost. Everybody, of course, wants to know how much this is going to cost. Very recently, we have gone out to shipyards on both the East and West Coast to ask about pricing. We put our own internal cost estimate together, wanted to go out and get a validation from real shipbuilders. This is very common in the way that we approach engineering in our industry. We estimated the cost at around $15 million for the cold ironing or the ship power, and $16 million for the harbor charging. That technology is a little more expensive. If you want to go, all in with the Swiss Army knife, we can put all of that together and do both. That's going to run you around $18 to $20 million. It's important to note this is for a completely new construction barge with all the bells and whistles. If you're repurposing an existing vessel, that will cut the cost significantly, possibly by as much as $5 to $8 million, depending on what you have to pay for the used barge, or if you can obtain one inexpensively at surplus. The estimates that we received from the shipyards that we approached are very close to validating these numbers. One is a little bit higher and a couple are a little bit lower, but in the current state of design, we feel that it's just right on the mark. We should also talk some about operational costs. In bunkering, when you're providing fuel to vessels, you typically operate a bunkering barge with a single barge master, You typically operate with a single master or a single tankerman doing that. Because this is very similar to bunkering, except that we're transferring energy in the form of electricity rather than liquid fuel, we are working with the Coast Guard to design the vessel to operate with a single crew member. Now, because this may stay on station for multiple days or at least more than one full shift, you may need two crew members, one to be on shift and one to be off, but it will only need one crew member to operate. And it is federal and state grant qualified, which I will explain here on the next slide. There is currently an open grant funding option through the Maritime Administration. And I honestly don't know with the latest mandate from the current president whether or not this is going to be revoked. But as of right now, this is an open grant funding option. It closes on April 30th. Has $450 million of total funding available at about 112 per state. And that checklist there at the bottom, those are the 4 key points out of 7 or 8 that make this, I think, very valid for funding for this grant. Port electrification, development of microgrids, most importantly, I think, reduction of idling of vessels, and then port resilience at that bottom check mark there. And the last thing I want to talk about today is where we're at in the process of making this ready to go to build. We have taken this design and this development of this program as far as possible as we can until a shipyard is selected to build the vessel and we sign a contract to do so. We have, I mentioned, obtained preliminary pricing from shipyards. We have engaged with the Coast Guard on a design basis agreement. And what that is, if you're not familiar with that, anytime you introduce a novel vessel that's never been done before, you have to work with the Coast Guard to actually write a new set of requirements, propose and write a new set of requirements, and then design the vessel to that. We are effectively at that point now with the Coast Guard. As part of that process, you conduct what's called a hazardous ID workshop. And that is usually administered by an independent third party. In this case, the Coast Guard and Elliott Bay selected the American Bureau of Shipping to do this. And we did conduct that workshop in October with 17, if I recall, 16 or 17 representatives from around the U.S. representing the U.S. Coast Guard itself, as well as a number of vessel operators and other key players in the industry in this project to go through all of the potential hazards and risks and what could happen if, what happens if it catches on fire, what happens if this happens or that, if the power cable is energized and becomes decoupled, and how do we mitigate those risks? How do we ensure those don't happen? So we went back and updated all of the contract plans and specifications that we developed to address those hazards and working with our technology partners. We've also established a long list of technology partners and also an operating partner, Centerline Logistics, who is one of the nation's leading bunker operators. They have been working very closely with us to help us make a plan for operating these. They would be the operator of us. We're the designer. They would operate these vessels if your port, should you need that kind of service. And then the last step in the process is to optimize each application for an individual port specific requirements, depending on the power level you need, the type of ships that you're serving, if you want small vessel electrification, if you want to be able to backfeed your power grid. How do we optimize those for your specific needs? That's the point where we are ready to begin construction. And so in closing, I just want to hit you with a few last key takeaways. I'll summarize everything we've talked about. Really key factors. Again, CHAMP is completely grid independent, certified and inspected by the United States Coast Guard. Again, that's really important because it takes away all of the shoreside permitting, all of the shoreside regulations, all of that. You have one regulatory body to satisfy and operate the vessel. No impact to your port or very minimal impact to your shoreside infrastructure. Very cost competitive with grid power. Please understand we have different fuel options, green or conventional diesel. Different fuel options are going to be right for different locations in the country, what you have available to you, what your budget is relative to how green you truly want to be. And then a long list of proven technologies that we are adapting to this. And it is compatible, as I said, with both big ships and small vessels, and we are effectively shovel ready at this point. So thank you for your interest and attention. That brings me to the end of the presentation today, and I will now open the floor for questions.
Will this recording be sent out to our emails? Absolutely. Once it downloads, I'll send it over as well as the slides. And Mike, tell them about your coffee chats that we're doing. They can get on your calendar for coffee chats.
Yeah, thank you, Bianca. That's great. So if anyone would like more information, obviously we kept this at a very high level for this presentation with some of the technologies and different things. How this would apply in your port and your specific needs, we would be more than happy to meet with you individually and talk about that in more detail. And follow up at whatever time is convenient for you. So if you're interested in that, please let us know.
Great. Thanks so much, Mike. I think that was a really great presentation. I'm looking forward to the slides and the recording to share with my team as necessary. I do have to hop off, so I just wanted to say bye, but it was great seeing you again.
Thank you. Thanks for joining us.
All right, guys.
You too. Bye. Something else to offer too, we will send this out in a link, and Bianca, I think we'll send this in a link. We literally just finished about a half hour before this meeting, a video presentation or a video clip showing the CHAMP, a rendering of the CHAMP coming up to a ship and connecting and how that all works. So the still photos were helpful, I think, but if you see the video of it working, we'll send that out as well. It's about a 2-minute video, and it's quite interesting. So we're excited to put that out into the digital universe. You'll be the first to get to see it. Any other questions today? Great. If not, well, I thank you all again for your time and for your interest in this. And again, please let us know if you'd like more information. We'll be happy to meet with you and discuss.
Thanks, Mike.
Thanks, Steve.